Welcome everybody. Today's lesson is all about the Benjamins. We're talking about compound interest. First of all, a little background. Interest is the money paid to a lender for use of their money. So this could be contributing money to a savings account or when taking out a loan. Either way, that money will accumulate interest. Now the interest rate is a percent of the initial money or the principal and is typically calculated either monthly or yearly. So for example, if you put $1,000 in a savings account with an interest rate of 5% a month, after the first month, $50 will be added to the account. In this chapter, we're talking about compound interest. And compound interest is when the interest gets calculated from the new amount in the account. So from our example, after that first month, the interest would be calculated from $1,050 in the account. So, the more frequently the interest compounds, the quicker the money in the account will increase. Let's look at how we calculate compound interest. Now, we can see that compound interest is an application of power functions. So the formula is a power function. First, let's look at the annual compound interest formula. This is for the case where the interest is compounded just once a year. That formula is shown up top here. You can see that it's A equals P times 1 plus R to the T power. Let's look at what some of those variables mean. The A represents the amount in the account. The P equals the principal, and remember, that is the initial amount. The R is the interest rate, and T equals time. So you can see for the annual compound interest formula, I'm simply taking the interest, adding 1 to the rate, and raising it to the time. Now one thing also to remember, that when we look at the rate, it's going to be as a percent. So if I'm given 5%, that written as a decimal is 0.05. That's going to be important to keep in mind. Now, the general compound interest formula is shown below. That's A equals P times the quantity 1 plus R over N, and that's to the N times T power. Now, N represents the number of times the interest is compounded. In the table, we can see some various quantities for N. If the interest is compounded monthly, N would equal 12. Quarterly, N would equal 4. Semi-annually, N would equal 2. In the case of it being compounded annually, N is just equal to 1. One last thing to keep in mind before we look at an example is that time could either be in the future or in the past. If time we're referring to the future, T will be positive, and if in the past, T will be negative. Let's look at how to plug these values into the formulas. So, when looking at example 1, we are going to calculate the amount in the account if $1,000 is deposited at an interest rate of 3.5% and look at the difference between compounding annually, semi-annually, or quarterly. Now, I'm going to set up the equation for each one, and then I've shown you the calculator display so you can see how to plug these numbers into the calculator. First, let's look at how to set up the annual compounding formula. The amount in the account will be equal to 1,000 times the quantity 1 plus 0.035 for 3.5%, raised to the first power, since time is just 1, because we're looking after the first year. The calculator display is shown below, and you can see that the new amount would be $1,035. Let's look at semi-annually. A equals 1,000, because that's the amount that was invested, times the quantity 1 plus, and now it's 0.035 divided by 2, raised to the 2 times 1 power, where 2 represents n and 1 is the time. You can see in the calculator display below, I simply raised it to the second power. My new amount is $1,035.30, just slightly more. Last, let's look at compounding quarterly. The amount in the account will be 1,000 times the quantity 1 plus 0.035 divided by 4 now, because that's the number of times it will be compounded, raised to the 4 times 1 power, where 4 is my n and 1 is the t. You can see in the calculator display below that I've raised it to just the 4th power. Also notice the use of parentheses. I've opened a set of parentheses for the quantity, and also a set of parentheses to do 0.035 divided by 4. It's important to use those parentheses so that we know what exactly is being raised to a power and what is being divided. Alright, you try one on your own now. Let's look at the first problem on the back. Do the on your own problem where Mrs. Rubino puts $2,500 in a 5-year CD that pays 7.4% interest. Then check your answer. You should have set up the equation A equals 2,500 times 1 plus 0.074 divided by 4 raised to the 5 times 4 power. 5 is time, 4 is n. If you plugged it in your calculator properly, you should have gotten 36.07 and 12 cents. Let's look at another example. In example 2, our unknown is going to be slightly different. Let's make sure we understand the information that we have. Going through the problem, I can see that R equals 6%. The amount in the account this time is $1,000. Time is 10 years. And I'm missing the principal. So let's set up our equation accordingly. I've got 1,000 equals P times 1 plus my rate, which is 0.06, raised to the 10th power. Now I'm using just the annual compounding rate because it says it is compounded annually. Now I'm simply going to solve for P. I simplify and I get 1,000 equals P times 1.79. If I divide both sides by 1.79, I get P is equal to 558.66, or $558.66 is the investment needed to earn $1,000 after 10 years at a 6% interest rate. Alright, one last example, and for this example we're talking about something called APY, and that's the annual percentage yield. The annual percentage yield tells us after all the compounding has been done, what percent should you expect after a year. Now, the way we'll set this up is completely the same as all the other problems, except we're going to use 1 for my principal. That's to keep the computations simple. So, watch how we set it up. the amount in the account equals 1 for my principal, and then 1 plus my rate. And since it's compounded semi-annually, that's divided by 2, and then raised to the second power. My amount, now I realize, is 1.0455. Now, I want to figure out how much did I gain over that year. So I'll subtract away my initial investment, which was 1. I see that what's left is 0.0455. So my actual APY for the year is 4.55%. It's just slightly more because I've compounded semi-annually. Now, you try the on your own where we'll calculate the APY when I compound daily. You should have set up the problem like this. A equals 1 times the quantity 1 plus 0.045 divided by 360 raised to the 360 power. We find out that the amount in the account after 1 year is equal to 1.046. If I subtract my initial investment of $1, I'm left with 0.046. So my APY is 4.6%. There you have it. You now know how to calculate compound interest, and you can find the APY for an interest rate. Come to class ready to answer questions, and remember, it's all about the Benjamins.